start introducing?
Yeah, hi guys, I'm Miss Kim. I'm from HPHPV.
I'm Mr. T. I'm from KV.
And I'm really excited to join our two campuses together, even though we're like half an hour away from each other.
Yeah, kind of. Depending on the traffic.
One in virtual world, which is pretty cool. Okay, so today, guys, first question. Did you know elephants had teeth? Did you know elephants had teeth?
Well, yeah, obviously the ones in their mouth, right?
But no, there's tusks. That's their incisor. Like this guy.
What?
Yeah, totally.
How do you think they brush those teeth?
They must be so gross. I bet they have to use like 10 tubes of toothpaste. Do you reckon? Maybe 20?
Probably.
I don't know.
Well, actually, that has something to do with what we're doing today, right?
No way.
So today we're going to be making elephant toothpaste, and we're going to be using different chemicals to make this reaction.
Maybe.
Yeah.
I mean, if it's elephant toothpaste, this is gonna be big.
Yeah, that's
It's gotta
right.
be big.
And do you know that 9 out of 10 dentists do not recommend that you use this stuff? So we're not going to use this as toothpaste.
Elephants, not us.
Yeah, that's right.
Okay, so how do we start?
All right, so I think to start us off, because this is the first virtual lab that we're doing, it's probably a good idea to go over some of the tools and the materials that we will be using. So Ms. Kim, do you want to introduce some of those tools that we will be using?
Yeah. First up, my favorite, the conical flask. Well, Miss Kim calls it the conical flask.
Fancier people call it the Erlenmeyer flask, but it's okay.
Take your pick. Conical flask or...
Erlenmeyer flask.
Okay. Then, next up, what have we got here?
That is the graduated cylinder.
We're going to use the 50 ml one, and we might have to be using it twice when later on we have to measure 100 mils.
Yeah. And fun fact, this is called a graduated cylinder because, one, it looks like it has a graduation hat. That's not actually why. It's because these little numbers right here, they are called graduations. So each one is a graduation, making this a graduated cylinder.
Woo woo! You go. Alright, next up is a beaker. This is a 100 ml beaker, but we get bigger ones too. Today we're just going to be using the 100 mils to help us out.
Yeah, that's right. So then, aside from these tools, we also have materials that we will be using. And so materials are usually the things that we kind of get rid of throughout the experiment. So we have, let me start with those fancier things. So here, we have dish soap.
Simple, what you use in your kitchen sink.
And then here we have food coloring.
This one's red, we can use any color, but today we're just going to stick with red.
Yeah, and so these two things are just here to help us show what the reaction looks like. Now the actual things that are going to react is this hydrogen peroxide. You might know it for when you have a scrape or a cut. Sometimes we use this. It is 3% of hydrogen peroxide, so it's a very weak solution, but it's going to give a pretty good toothpaste effect.
And Mr. T, when you have a high concentration of hydrogen peroxide, that's pretty dangerous, right?
That's right.
Yeah.
We use this because it kills bacteria, so anything higher than 3% could kill actual living things.
Yeah.
So we don't want to do that. And the last thing here, this is the special ingredient that we are going to use, taken from the lab of PV.
Whoop whoop.
This is potassium iodide, and we're going to be using this to react with the hydrogen peroxide.
Woo.
So those are all the tools that we will be using.
Oh, and a spoon. Spoon. We'll need this to measure.
Okay, so now that we have all the materials explained to you, we're just going to introduce two little simple things that we're also going to use to make sure that we're keeping this area safe, but also to make sure we can pour things easily. So Ms. Kim would like to show your invention there.
Simple piece of paper that I just kind of twirled around, used a few staples to keep it in place and a little bit of tape, and this is going to be our funnel.
Why would we need that?
Well, we noticed, where's that spoon that we're going to use? Yeah, so this spoon, we've got to try and get the solid stuff into this small little hole. And if we do that, we're going to probably lose some onto the side. So I'm going to use a funnel to make sure that all the potassium iodide gets into the conical flask.
Very nice. And we're also using a towel here because we realized we need to keep washing this tray because we want to keep everything clean. And in order to not have to go and dry it every single time, we're using a towel. So just a couple of changes that you may have noticed.
Cool. All right. Should we do it?
Yeah, let's do this. So, let's do the first part here. We are going to start with putting the solids in first. And it's usually a good idea to put in the solid materials first, just because it's easier for liquids to flow. And for solids, like Miss Kim said, we want a little bit more time and a little bit more effort in putting it in so that nothing spills out.
Yeah, makes sense.
All right, so we're gonna use a little bit of teamwork here, and she's gonna hold the cone. I'm going to put this onto the spoon. Just see this out. And we're just gonna let's use half a teaspoon-ish. So there, right there. And we're going to try to use this amount every single time so that it's one of the variables. Now, you guys could say in the chat, which variable is this? Is it a dependent, independent, or control variable?
Yep.
All right.
Then that would make it a fair test, right? When we keep on doing the same amount every time.
That's right.
Fair.
All right, and so now the next part, we're gonna leave this aside for now, and we're going to put all the other mixtures in there. So we're going to start with
hydrogen peroxide.
Now, would it be a good idea, Miss Kim, if I poured this directly into the graduated cylinder?
Well, I mean, we kind of have that problem with the funnel again, but my funnel is paper. You know, I think to be safe, how about we use this one? You see it's got a bigger mouth. I think that would be safer, especially because remember, hydrogen peroxide, we don't really want it spilling everywhere.
That's right. Now for this one, we don't need to be too exact with the measurements because we're going to pour everything into there. So I know that we're going to be using this experiment several times, so I'll just fill that up to about 80 right there, and then we can just reuse it and add more if we feel the need to do that.
As we go? Cool.
Yeah. All right, so what was the first measurement that we're going to use here? I think we're going to go for 25.
Yeah, I think that's a good idea.
All right.
Let's just see what happens.
Yeah.
Yeah.
So we're going to start by pouring 25, and at the bottom you're going to see a little bit of residue from the previous activity that we tried doing, and that one there's a little bit of soap. So usually, you know, we could clear it up a little bit more, but in this case we figured we're going to be pouring the same things in the whole time, so
yeah,
it's kind of okay to let that slide. And so the next thing that we'll pour in will be
sure. Remember, just the one from your sink. And then how many drops? Like
we said about 3 or like 3 seconds worth of just letting things go in. 2, 3, and so there's that.
And then we're gonna do that again the same amount every time, right?
Yeah.
And maybe you guys can type in the chat, why are we doing the same amount every time?
Mm-hmm. And one thing that we can do when we're stirring things or mixing things in chemistry is we don't use a spoon because we might be taking some chemicals out. So using these flasks, we could just hold and we could just swirl. Yeah, and in other experiments, if you ever have this, you could also use this to swirl as well. So it's actually a lot easier to swirl, and this is why people do like using this, because it's as big as a beaker, so you can swirl things easily, but they won't spill because of the cone.
Yeah, makes sense.
So anyways, I'm gonna keep doing that.
Yeah, mix it up in there.
Yeah.
It's looking good.
Now, how much of this should we put in? Would you like to put this in?
Oh yeah.
It's pretty strong, and one of the things students do is they put a lot, so we'll just put a drop in there. And there we go. And you can see how thick the color is, right?
My PV kids, good impact, yeah? Tell Miss Dinder about it.
Yeah.
KB, if you're wondering, I think some pictures are getting posted on Instagram. Quick shout out.
All right. I think that's it.
Okay, all right, I'm ready. Are you guys ready to see some elephant toothpaste? Okay, let's see.
All right, would you like to do the honors? And
okay, here we go. Can I have a countdown? 1, 3.
1. Ooh.
What?
Yeah. So one of the things that you can feel is there's a little bit of steam in
Yeah, feels really warm.
Mm-hmm.
Whoa, check that out! Can you imagine that being like a toothpaste tube being squeezed?
So that's why it's called elephant toothpaste.
Cool.
So I guess we shouldn't be using it for toothpaste for our pet elephants, huh?
Yeah, maybe not. It should get rid of all the bacteria on it, though.
Yeah, that's true. All right, so that's the first part, and so we are going to try to experiment with a couple of different independent variables.
Yeah.
And so one of the dependent variables that you can see is the amount of foam coming out. And the independent variable that we chose is the amount of
hydrogen peroxide.
So we're going to be changing the amount of hydrogen peroxide. This one, we put 25 milliliters.
Yep.
For the next one, how much do we say we're going to put?
50 milliliters?
All right, 50 milliliters.
Yep.
And then, should we do a bigger one too?
Oh, yeah.
Ooh.
Go big or go home. 100?
Yeah. All right, let's do 100. So we're going to do 50 and 100. You guys should make predictions on, do you think the amount of foam is going to increase by a lot or decrease, or what do you think?
Cool. Based on your observation here, write down in the table in your notes your prediction for when we add 50 mils of hydrogen peroxide, keeping everything else the same.
All right, now that you've made your predictions, we're going to go to the second part of this. We are going to put 50 milliliters of hydrogen peroxide,
Yep.
which is more. How much did we put in the first one?
We put 25 mils the first time, so this time it's going to be double, right? Yep.
Yeah.
Okay.
All right, so to keep it consistent, we're just going to start by pouring this, the potassium iodide, first. It's going to be the same amount. And now,
I'm going to make sure I tap it just to make sure everything gets into the conical flask.
yep. And now we're going to be repeating the steps. We're just going to be pouring more hydrogen peroxide, so we're going to fast forward through this one. And go. All right, so now we have poured 50 milliliters. If you saw, we took a little pause there when we were filling it up. Why did we do that?
Well, you would have noticed it took quite a while for that food coloring to get all the way to the bottom. So because of the design of this graduated cylinder, when you try and mix it, it takes a little bit longer. So if we just like half filled it, or I filled about 3/4, then we mixed it, and then we filled it up right to the top, that just helps to let all that soap and the food coloring get mixed throughout.
Yeah. All right.
Cool.
So, again, make sure that you have your predictions, because here we go.
Truth.
Do you think there's going to be more foam, less foam?
Okay, let's see.
Let's see.
So far this is looking good. I can definitely see it's like coming out a little bit faster.
Yeah, there's a little bit more bubbles on the top there too.
It's the heat, like, oh wow, I can feel it. Yeah.
Oh yeah.
Wow. I think the spread's more, hey?
Yeah.
Kind of looks like we're about to make a crepe. I don't know, that's what makes me think. But I should really be thinking the elephant toothpaste, right?
Or that, yeah.
Let's see if it starts to make that shape. Because with the other one, the shape started forming really quickly, hey? Whoa, Jake, there it comes.
All right, so I think that's about it, right? We did feel a little bit more heat, something you couldn't feel throughout, but maybe you could see a little bit of steam. I'm not sure what the camera picks up. But yeah, so that's the first hypothesis that you have. And now, should we do one more, right? Like we said?
I think so. Let's take it up a notch. Maybe 100 mils, like just
right.
double it again.
Yeah, sounds good.
Okay, make your next prediction. Do you think there'll be more foam? Or not? I don't know. Make your prediction.
So now, we're gonna go into our...
Third time. Damming it up again. So we're going to use same amount of potassium iodide again.
All right.
Keeping that the same.
Just about half. Oops. There's a big clump here that I don't want to get. There we go.
Okay, make sure it goes in there. Okay.
All right.
Okay,
Oh
next
no.
up.
Now, looks like we only have 50 milliliters in here.
Okay, how are we gonna tackle the problem?
So, what we're going to try is we actually have this beaker that has 100 milliliters. And if we do go all the way up to the top where this lip is right here, that's 100 milliliters. So,
Perfect.
do you think we could use this?
So that can work. I think that can work. The only thing is we've got to mix it, right? So we can't use a spoon because that's just not what we've been doing before.
Mm-hmm.
Okay, so I think we should probably use this first. Yeah?
That sounds good.
Okay.
So what you're about to see in our little fast forward is we're going to pour it in here so we can mix it up, like Miss Kim
Mix
said.
it up.
And then we'll put everything back in here and we'll add some more hydrogen peroxide to top it off.
To top it off.
Are we going to add more soap or food coloring though?
I think it needs to be all the same, right? So
Mhm.
just we'll add it all into here in the first time, and then we'll just top it off with the hydrogen peroxide. So then it's all the same.
Sounds good.
Because I mean, we got to keep it fair, right?
Yeah. So do you want to do the fast forward snap?
All right, let's go. All right, and we're back. So we have our mixed 100 mils of hydrogen peroxide, dish liquid, dishwashing soap, and food coloring. Now I'm gonna pour it into this conical flask with the same amount of potassium iodide.
Yeah.
Okay, double check your prediction. Make sure you know what you said. Okay,
Mhm.
you ready?
All right, let's do
give
this.
Me, give me a countdown again from 3, 2,
2, 1.
Go, 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 Miss Kim.
There we go. Nice.
All right. Whoa! Oh man.
That's way more liquid than the other ones.
That's really interesting.
Mm-hmm.
It's
it
a little
warm?
bit different.
Mm.
I can't feel it as much. I mean, a little bit.
Yeah.
It's not as impressive,
Mm-hmm.
but. The other one was more like a flapjack. This one's like a crepe, much thinner.
Yeah. So it does look like there's much more foam, right?
Right, like it's spreading out. But
yeah.
it's definitely not as like thick. Like its viscosity is maybe lower.
Mm-hmm.
Viscosity, like thickness, or.
Yeah.
Ooh, but it is making the nice elephant toothpaste.
Mm-hmm.
It does seem to have gone out further.
That's right. So if we are measuring it based on the amount of foam,
Yep.
it looks like the more we add,
Yep.
the more foam you get, huh?
From again, yeah.
Okay, so that's something that you can use as your conclusion. If you are interested in discussing why you think the quality of the foam is a little bit different, then maybe you could also write that down as an additional piece to your conclusion.
That's a good idea,
if
yeah.
you have theories. And we can come up with an additional video, just in case you want to see it, if you want to understand why it didn't react as well as the second one, probably.
Yeah, it's a good plan.
All right.